Welcome, ladies and gentlemen. This is video number 3 in our atomic structure unit. Again, you're going to need your notes open to video number 3. Having the periodic table open would also be helpful. And if you're not super comfortable with simple arithmetic, then a calculator function would be helpful as well. In this video, I'm going to talk about ions, go into a little more detail. I know you learned it in the POGL, but just make sure that everyone's really confident about it. So we're going to be describing how ions are formed, and then we're going to be determining the number of electrons in an ion. So first of all, what is an ion? It is a positively or negatively charged particle that came from an atom. So the big thing that we talked about with atoms is that they're electrically neutral, amongst other things, and that the number of protons is equal to their number of electrons. Well, I said that that could change, but if it changes, then we don't call it an atom anymore. So ions come from atoms, but they're what happens when now we have a charge. So ions are a charged particle from an atom. Now, how do we get an ion? Well, you can't change the protons because they're all the way in the middle of an atom. They're difficult to change, and then you change the element. But we can change the other charged subatomic particle, which is electrons. So we form ions when an atom gains or loses electrons. Now, the reason that an atom would want to gain or lose electrons has everything to do with what's called its electron configuration, which now you can think about it as its electron count. How many electrons does it have? Because all the elements on the periodic table experience what I like to call noble gas envy. The very, very last column of the periodic table, which is called group 18, it's these guys right here. That's the group number that's on top. These are all the noble gases. And these elements all have stable electron counts. They have a stable number of electrons in them in what's called their electron configuration, which we're going to go into a lot more detail later. And every other element is basically trying to be like them. They're trying to achieve a stable number of electrons like the noble gases have, like helium, neon, argon, krypton, xenon, and radon. So you'll just notice that electron configuration is actually shown on your reference table. So for the noble gases, it's these numbers right here. And the big thing that makes it stable is actually the fact that they all end in 8. 8 is a very stable number of electrons in chemistry. So every other atom will want to try to either gain electrons or lose electrons to become like the noble gases, because that makes them energetically stable. It gives them a very low energy. Things like having low energy, it's very stable. So ions, because we're talking about a change in electrons, that atoms are either gaining or losing electrons to become ions, you have to remember that electrons carry a negative charge. So sometimes students get confused about gaining versus losing electrons and what would happen to the overall charge on the ion because of that. So a positive ion is one where you lost electrons. Because remember, electrons are negative. So if you lose a negative, if you get rid of a negative charge, you actually become more positive. I like to explain it this way. Think about, like, if you had someone or something in your life that was a negative influence. If you have like a friend who's a super real downer and kind of ruins things for everybody, that's a negative person. And if you cut that person out of your life becomes more positive, right? If you lose a negative, if you lose that bummer friend, then your life becomes more positive. So if an atom loses electrons, it becomes a positively charged ion. Now we actually call this a cation. We have a name for that, and that's not pronounced cation. It is pronounced cation because we want to keep the ion there. So a cation is a positively charged ion. And then we get a negatively charged ion if we gain electrons. So if the atom takes on additional electrons that it didn't start with, now it has a lot more negatives than it does positives. So now it has a negative charge, and we call that an anion. I'll be talking more about those two words, cation and anion, in class. So this is a number line now sort of explaining this effect. An atom is electrically neutral, so that means that the number of protons is equal to the number of electrons in an atom. But then we have two possibilities to form an ion. We can lose a negative electron. So you get rid of a negative. Now there aren't as many negatives. So that means now that the number of protons is actually greater than the number of electrons. You have more protons than you do electrons because you lost electrons. So now you have this positive charge. Right, +1, +2, +3, +4, +5. And for every electron that you lose, your charge becomes more positive. On the other side is gaining a negative electron, starting off with the electrically neutral atom, but then gaining some electrons in, adding some electrons in that weren't there before. So now the number of electrons is greater than the number of protons, because protons are not changing. We're not changing the element, we're just making it an ion instead of an atom. Having more negatives than you do positive means that now we're going to have these negative charges. -1, -2, -3, and the more electrons for each electron that you gain, the charge becomes more negative. So this is an example then on the bottom, sort of showing an atomic diagram of what's happening. You've got your nucleus in the middle. The nucleus is going to be unchanged. And then for this diagram, you've got 2 electrons in the first shell and 4 electrons in the second shell. That atom can kind of do, for this example, it can do one of 2 things. We can gain an electron. So notice that this electron here wasn't there before. So this is our gained electron. So now there are 7 electrons total. There's more electrons than protons. So if this is a negative ion, this would be a -1 charge for the one gained electron. Or we can lose an electron. And there's this spot here that had an electron before, so this is a lost electron. So now there are fewer electrons, than there are protons. There are a total of 5 electrons rather than the 6 that we started with. So this would be a +1 charge on the ion, right? This is a positively charged ion, or a cation. Looking at this again with a little more specific element, if we have sodium, the sodium atom contains, go to your periodic table, you want to look up sodium, that's Na. The sodium atom would contain 11 protons, and because it's an atom, it would contain 11 electrons. There are 11 electrons in this picture. But sodium wants to achieve a stable electron count like the noble gases. So in order to do that, it will lose 1 electron. And it's this one right here. Notice a couple of things, right? Notice that the last shell, electron shell, is now gone. We're going to come back to this idea later in the year about what that means for the size of the ion. But we're now 1 electron down. So now this is the sodium ion. It's not an atom anymore. Now it's still sodium, so it still has 11 protons. But if you count it up, now it only has 10 electrons, so that we've got this loss of 1 electron. If I was writing that out as a symbol, I would write the symbol for Na, but then in the upper right-hand corner, I would write a +1 charge to again indicate that it lost 1 electron. If it lost 2 electrons, it would be +2. If it lost 3 electrons, it would be +3, etc., etc., etc. But really, our big goal for this is to be able to determine the number of electrons in a sample. So I've got this Mg2+ symbol, and we want to be able to figure out how many electrons are in this thing. So we want to start with the number of protons, and that's what we're going to get from the fact that it's Mg, because every Mg has the same number of protons. So we go to the periodic table, we look up Mg, and we see that Mg has 12 protons. Now, an atom of magnesium would also contain 12 electrons, but this is not an atom. This is an ion. So its number of electrons has changed. Now, hopefully we can tell from the +2 that the number of electrons changed by 2. So basically, we know it's either going to be 10 electrons or 14 electrons. It's not going to be 12. Then the question is basically, which direction are we going? This is a +2. which means in order to get a positive charge, you have to lose negatives. Right, and so in order to get +2, we must have lost 2 negatively charged electrons. So the ion of magnesium, instead of containing 12 electrons, we're going to subtract away the 2 that it lost, is going to contain 10 electrons. And that's really what we want to be able to figure out, is that that ion has 10 electrons rather than the 12 that the atom started with.